Hi everyone, today we'll be solving LeetCode question 136, which is single number. Before entering any coding question, there are two things which needed to be followed. Step number one, know the question clearly, know what are the objective of the question so that it will give you more clarity over the coding while doing the coding thing. So, and step number two, know what are the constraints are. So constraints are nothing but know what are the output and what are the input and what are the input ranges are, so that which gives more clarity over the question. So now we step into the question. So here they have given that given a non-empty array of integers nums, every element appears twice except for one. Find the single one. You must implement a solution with a linear runtime complexity and use only constant extra space. So the thing in the question is, the main objective of the question is to find the non-duplicate number. And they have given one more condition that we need to find the non-duplicate number with a constant space, which is order of 1. So first of all, keeping all this aside, we know what is the purpose, what is a main objective of the code question is. So uh, first thing, uh, in a brute force way, for me, at first, I thought to implement a hash map, which is a good approach, and it takes a order of n time, which is nothing but storing the here you can see, right? Yeah, in a, in a hash map we need to maintain a count of variables. So uh, after maintaining all the count, after traversing all the array, so we will maintain the count of each variable, so that if any variable which has count 1, so it is a single variable, and which takes order of n space, which is nothing but taking the memory, using the extra memory hash map. So, but in the question they have given that we need to use only the single, what we will say that, uh, constant space. So for me, later on, I thought to implement. I got an idea that why can't we just sort, and why can't we check the adjacent elements, so that if adjacent element is doesn't match, so that is the single element present in the array. Let me show my code. Yeah, here you can see, right, I have sorted this thing, so that let let us take this example. So after sorting this, if adjacent element doesn't match here, one doesn't match to two, so the single element present in the array is one. So that uh, you may think that what if the element matches, right? If element matches, we need to increment I by 2, so that it it will skip these two elements and come to the new element. Otherwise, if 3 is there, it comes to a new element here. And what if the case means, here you can see, right, I is less than size of the array minus 1, so it doesn't cover the lost element. If no duplicates are present for till now, means up to this element point, for suppose here is the case. So if no duplicates are present from here 1 to 1 and 2 to 2, and it will loop ends. So after loop ends, so the single element should present at the lost position. So that's how the here is the logic. So which takes order of n log n. uh, if here I'm using the built-in sort function, which is stl sort function, so it implements in time complexity of order of n log n. If we take any other sorting techniques, if it comes in the worst case scenario of order of n square. But yeah, as we are using the built-in sort function, takes a time complexity of order of n log n. But there is another better approach than this, which is uh, using XOR operation. Which First, before using the XOR operation, we need to get the intuition of the what is the purpose of using the XOR operation. Here you can see, right, this is the XOR operation. So XOR of 0 or 1 is 0. This is the main intention of using the XOR. So XOR of two different numbers is equal to 1. Two different numbers are, it's nothing but 1 or 1 XOR 0 is equal to 1. So main objective of using XOR is, as in our array there are multiple duplicate elements are present, which will be present only two times. So if we make XOR of both elements, it will be 0. Let me explain with the example. So now let us take a example of this case, 2221. So that, yeah, so that doing the XOR for the 2, you know the uh, we know that the value of 2 in the bitwise is 010, which is, yes, here, yeah, 010. And bitwise bit value of 1 is 001. So XOR of 0 and 0, which is 0, XOR of 0 and 1, which is 1, is equal to 1. And XOR of 1 1 is 0, and XOR of 0 is to 0 is 0. And similarly, you can see here, right, XOR of both the operations, which removes all the duplicates. So if you don't understand this logic, let me make it more simple. Here you can see, right, yeah, let us keep all those things aside. Means just assume that we know that x of 1 is to 1 is equal to 0, which is nothing but XOR of any number is to XOR of any number is equal to 0. So XOR of 2 of XOR 2 is equal to 0. So which removes all the duplicates. One more benefit of using XOR is that if we do XOR of any number to 0 is equal to that number. So we don't lose any information of that number. So here you can see, right, in the question, 2 XOR of 2 is 0, and 0 XOR of 1 is 1. So the single element present in this whole array is 1, and which follows same for this number also. Yeah. uh, Let us code. Yeah, here, uh, first, as I mentioned it, we know that what is the purpose of the code and what are the things we need to be maintained at, and we need to know what are the constraints. Here they are given that the constraints are number of array length will be 1 to 3, 3 into 10 power 4, and a number value which will be in the integer space only. So here you can also see that array any number will be in integer only, so there is no need of using the float or double or long double. So let's define here x is equals to 0. As I already mentioned that XOR of 0 to any number is that number. So x is equals to 0. Then again, for int I is equal to 0, I less than nums dot size, yes, then I plus plus. Now, yeah, now we need to do the XOR to this array of integers. So x is equals to XOR of nums of I. That's it. And x. You may think that how this work means, uh, this is the function which, yeah, this is the function which automatically does all this XOR operation in the bitwise. So yeah, so it works for every bit of integer. So you just think it in a different way. Yeah, think. Yeah, that's it. And this takes order of n time, as it is iterating to a whole loop at once only, and it takes order of one space, which we have been not using any additional space. That's it. Thank you. If you have any questions, feel free to ask in the comments, and please make sure to subscribe to this channel. Thank you.